Today we're going to talk about section 2.2, more on functions and their graphs. This lecture will also be split into two parts. Part 1, we're going to talk about how to identify intervals where a function is increasing, decreasing, and constant, how to locate the relative maximum and minimum values, and how to use symmetry to determine if a function is even, odd, or neither. So our first topic is identifying intervals on which a function is increasing, decreasing, and constant. Means to find the x values or x intervals for which the function values, meaning y values, have the indicated behavior, meaning are the y values increasing, are the y values decreasing, or are the y values constant? It is important in these problems to make sure you are reading the graph from left to right and that you're using interval notation to state your answer when applicable. Okay, remember you're stating the x values for which the y values have the indicated behavior. So we're going to look at this graph to do our first example. Use the graph above to find the intervals for which f is a increasing, b decreasing, and c constant. So if we read the graph starting on the left, okay, far left, as I move forward, we see decreasing behavior. In other words, the y values are getting smaller until I land right here. Past this point, we have a change in behavior. The graph now has increasing y values until I land right here. And then continuing from here, we start to see decreasing values again until I get to here. And then after here, it starts to have the increasing behavior. So it goes back and forth between decreasing and increasing. All right. So increasing, we're looking for the x intervals for which the behavior is increasing. So if we started on the far left, we first saw decrease until we got to here. So beginning right here, which is the x value -3, moving forward from there, we see increasing, and we see it stop increasing when I get to right here, which is, remember, the x value 0. So between the x values of -3 and 0, we see increasing behavior. So that's my first interval, -3 to 0. Then again, once I got to this point right here, which is an x value of 3, moving forward, I know the y graph is going up, that's increasing behavior, but when I list my interval, I'm talking about what's happening to x, it's moving to the right, so it's going toward positive infinity, indicated by the arrow. So from x equals 3 to positive infinity, in that space on the x-axis, the y values are getting larger or increasing. So my two intervals would be between -3 and 0, it increases, and then again between 3 and infinity, it increases. So these are the x values for which the y values are increasing. F is decreasing on, so if I start on the left, right off the bat, I start to see decreasing behavior. So on the far left, because there's an arrow here, we would assume that we would be continuing off to the left. So that's -infinity, as in x starting value, all the way up until I land at x equals -3. So for x is between -infinity and -3, the behavior is decrease. Right? Then again, once I got to here, this was x value 0, remember, decreasing behavior until I get to the x value of 3. So between the x values of 0 and 3, we see decreasing. And this graph is never constant. Constant would mean a straight flat line. In other words, y values remaining constant throughout an interval, which is not the case on this graph. Okay, we'll do another example of that later. Next, we want to talk about how to identify a relative max and a relative min. So here's an example of just a random function f of x. This location right here would represent what we call a relative max. Okay, we use the word relative because it's not the highest value ever, because over here you're going to have higher values on your graph, but it's kind of the top of a hill within the domain. Similarly, this spot right here would be referred to as a relative minimum. Again, it's relative because it's not the absolute lowest point because there's lower y values over here, but it's kind of the bottom of a valley within my graph. The notation and the vocabulary on these problems is a little bit confusing. They'll ask you in the homework to identify what is the maximum or minimum value and where does it occur, or for what x values does it occur. So we would say this graph f of x has a relative max at f of a. That's this y value right here. And that max occurs at the value x equals a. So when x is a, the relative max of f of a happens. So where it occurs is the x, the actual value of the max or the min is the y. And then our f of x has a relative min of the value of the relative min is f of b, it's the y value right here, and it occurs at the x value of b. So we're going to look at that same graph we did earlier, and I talk about relative mins and maxes. So this would be considered a relative max, and both of these 2 points here would be considered relative mins. So we could say on this graph that the relative max of f of x is 4, that's the y value, and it occurs at the x value right there, which would be at 0. This graph has a relative minimum value of 0, right here, and again right here, and it occurs at the two x values of -3 and 3. So the relative max or min is the y. It is occurring at, or for which it has the relative max or min, represents the x's. All right, our next topic here is deciding whether a function is even, odd, or neither. And this has to do with, there's a definition that we'll talk about, but it's a lot easier to identify it just by looking for a certain type of symmetry. So we say function is even if f of negative x is equal to f of x. So in other words, when x changes sign, the y values stay the same. So x can be a positive value or that same number but negative, so it would be the same distance away from 0 on opposite sides of the y-axis, but the y values are the same at those two spots. If that's true for all x in the domain of f, we say that the function would be even. When this happens, if I'm looking at a graph of an even function, it will have symmetry with respect to the y-axis. Meaning if you folded the y-axis, the two parts of the graph would match up exactly on top of each other. So the graph above would be even because it has y-axis symmetry. Right here, if I were to fold the y-axis right down this line, right, this side would land directly on top of this side. Okay, notice that when x is 3, we have a y value of 0. When x is the opposite, -3, we also will have a y value of 0. That happens for every value of x. If x is 1, the y value is 3. When x is -1, the y value is also 3. So this relationship causes it to have symmetry about the y-axis. All right, we would consider a function to be odd if f of negative x is equal to the negative of f of x. So all this says is that when x changes sign from negative to positive, the y, or the f value, also changes sign. So when x changes sign, y changes sign. So it's going to be like it folds twice. You're going to fold it along the x-axis, or I'm sorry, the y-axis when x changes sign, and then you'd also fold that result along the x-axis to decide whether or not it's odd. We call that origin symmetry. The graph of an odd function is symmetric with respect to the origin. Here are two examples of an odd function. Notice if I fold it along the y-axis, this piece would land over here. And then if I folded that along the x-axis, it would land on top of the other the other piece. That would also happen on this example. If you fold it along the y-axis first, this right side would turn over to this side, and then if I flip that upside down, it would land on top of this piece down here. That's what we call origin symmetry. So here you have the ordered pair 1, 1. If you change the sign of both, -1 for x, -1 for y, you'd land down here. All right, so let's look at this graph and try to kind of tie a lot of this stuff together that we've talked about these last couple of sections. So looking at this graph, we want to answer all of these questions. Part A says find the domain. All right, so notice we have arrows on both ends. It extends as far left as we could go, and then eventually it will extend as far to the right. So our domain would be all real numbers, using interval notation, -infinity, comma, infinity, with parentheses on the ends. Range, y values from bottom to top, smallest to largest. So the bottom of this graph, it will never go lower than this spot. That's y value of -4. And then to the left of that, we come up and kind of flatten off here at 4, but on the right, we would continue up and never stop. So the lowest value being -4 with a bracket, comma, largest value then not having a top because it's going to go toward positive infinity. So -4 to infinity. X-intercepts, where the graph touches or crosses the x-axis at x equals 1 and at x equals 7. Y-intercept, where it touches or crosses the y-axis right here at 4. Intervals on which f is increasing. So let's start on the left and move to the right, left to right. So we see constant behavior first when I get to here. Then if I keep going, it's decreasing behavior until I get to here. So beginning right here, which is the x value of 4, moving forward from there, so x moving toward positive infinity, the y values are increasing. So from 4 to infinity, increasing. Intervals on which f is decreasing. In other words, starting on the left, moving forward, starts off constant. Once I get to this spot, which is an x value of 0, continuing forward from the x value of 0, we see decreasing behavior until we get to here, which is an x value of 4. So between the x values of 0 and 4, the graph decreases. Part G, intervals on which f is constant. So starting out here on the far left at -infinity, it's constant all the way up until right here, which is 0. So from -infinity to 0, we have constant behavior. Part H, the number at which f has a relative minimum. The number at which it occurs is the x. So here is the min. So the number at which it happens is 4. And then part I says the relative minimum, that's the value of the function, -4. Part J, f of -3. So that means if x were -3, find what y is. So here's x equals -3. Go up to my graph right here. Y value right there is 4. So f of -3 would equal 4. The values of x for which f of x or y equals -2. So this is like telling me y is -2, figure out what x is. So if y is -2, we're down here. So I got to go find my graph. That happens right here at the x value of 2. But y is -2 also over here, which is the x value of 6. So there's 2 different values for x. X at x value 2 and 6 is where the y value hits -2. And then part I says is f even, odd, or neither. This one happens to be neither because if I fold the y-axis, the two pieces are not the same, and they're not the same if I had 2 folds, right? This graph would not match up. This quadrant would not match up with something down here or vice versa. So this is neither origin symmetry nor y-axis symmetry, so this would be considered neither even or odd. Okay, so we're going to stop here for part 1, and then we'll have a separate video posted for part 2.